Hello everybody, and welcome back to Mountain Computers. Today I have a mini product unboxing to show you guys. I recently purchased a Tripp Lite battery backup uninterruptible power supply unit as part of a somewhat larger project I'm working on for the channel, and I figured that we would go ahead and take a look at it before I put it into use. So this is the INTERNET750U, and it is an uninterruptible power supply with a set of ports on one side, which I believe is battery backed up, and a set of ports on the other side that is not, but does still go through some power filtering circuitry. So that is, generally speaking, a nice thing. It has some filtering for, I believe, telephony systems as well as internet-based systems. So you have your RJ45 style jacks and RJ11 as well. And there's also a communication port on board in the form of a USB Type B port. So I think what we're going to go ahead and do here is open this up next. We've got a couple insert leaflets. This is just a listing of Tripp Lite products. It's not super interesting. Here we've got what appears to be a similar deal. There is an instruction manual, it appears, and then a USB Type A to B cable. Very nice that that's included, I would say. And then if we take the main unit out here, we can get a look at how it appears as well. So, here we go. We've got, yes, one side a set of battery backed up ports, and on the other side a set of just power filtered ports. There appear to be some status indicators here, and then if we come around this end, I believe this is the insert for the reset button. Yeah. A set of ports over here for RJ45 and a USB port here. Now, I believe I saw on the box that they have telephony as well, but I don't see the ports for that. So either the box wasn't quite correct, or I misremember having looked at it. All right, yeah. So on the box here, I guess it says tel/network line protection. What they may mean by that is that the network is telephony, and I guess in some certain respect they are correct in that manner, but that is certainly where the confusion came from on my part. Let's go ahead and talk about why someone would necessarily want to use one of these battery backup units. So as I alluded to before, basically the idea is that the ports along this side are hooked up to an internal sealed lead acid battery, which can be opened up down here and replaced when needed, in order to make sure that any items that are plugged into these ports, should you lose mains power input from this cord, will continue to operate as normal when they're not receiving external power. So in the event of a power outage, basically, whatever you have running will continue to run until either the devices realize that they should turn themselves off and do so, or the battery just runs out. So in order to demonstrate that, why don't we go ahead and get this unwrapped here and take off this cover, and then I'm going to plug this into a little power strip that I have set off to the side here. And if we go ahead and hold down this button, we should see the unit go ahead and turn on. Now, the ports on this side are not active unless you have the battery unit turned on via this button here. And that's where these status lights come into play. And then the ports on this side seem to just basically always be active as long as you have mains input power. So let's take a brief closer look at these status indicator lights. There are 3 of them, and they're all telling a slightly different narrative about what's going on with the system. Now, the really high-level view of what these do, the simplified version, is that this leftmost one is displaying whether you have mains input being received or not. So if I flick our power strip off screen, then you'll see that we get an off scenario there. If I flick it back on, comes back on. You hear a relay click internally. The second light is battery output power for these outlets. So if we were to hold this button down that actuates the battery feature, then you'll see that we get the lights turned off there. If we turn that back on, then we see a test scenario where all the lights show up for a second and then the battery comes back on. And then the light on the rightmost side is a battery indicator light for warning you that the battery has reached nearly depleted state and that it is about to turn off. But if we were to go ahead and look in our product manual here, then there are actually a few other conditions that we can look at. There is an indication for the line mode overload alert. That is to say that the input through a line in is receiving overloaded power. Now, if you were in that state, you would have both of these lights on and this one off, just as is currently the state. However, every half of a second, the machine would start to beep. There's also a battery mode overload alert where this battery light begins to flash, and again, every half second, you'll hear a beep. There's also a line mode overload fault. Now, that is going to turn off both of the leftmost lights and turn the rightmost one on, and the alarm is going to just be continuously on. If the battery mode, however, winds up with an overload fault, then everything is going to turn off on the unit. It'll be as if it's not plugged in and not turned on at all. If you need to replace the battery, then the battery indicator light will continuously flash about once per minute, and the sound alarm will also alarm once per minute. And there's also a fault condition in which all of the lights are also off and the alarm will continuously sound. Pretty similar, actually, the warning light turns on for that one, I'm sorry. However, that's basically the same output that you get for a line mode overload fault.
So it seems like some of the audio at the tail end of that clip wound up getting corrupted, so overdub Matt here to talk to you about those alert and fault conditions and how they get triggered. So the alert for the line mode input winds up getting triggered at 110% of the max rated power throughput, plus or minus 10%. And that will, if it continues to stay in that state for 5 minutes, eventually just enter a fault state instead. Normally, you can just immediately trigger that fault state too if you're at 120% of the max rated power throughput, plus or minus 10%. When you're talking about battery power and the throughput on those outlets, though, if you're at 110% again, plus or minus 10%, that'll immediately put you into the alert condition. But if you stay in that condition for only 5 seconds, then the output will get shut down. And again, if you go 120% plus or minus 10% over the max rated throughput, then that's going to shut down immediately.
Let's test this out using a little Dell Optiplex 3020M that I have. Just a small computer that should work okay for demonstrating whether power is being received by the device or not. So we'll start with the very basics of plugging into the regular side. This should operate just as a normal power strip with some good power filtering. So if we turn the device on from here, we'll see that we are getting power. However, if I just flip the switch on our out of shot power strip, immediately we're going to get a power off situation. So that is exactly what we're trying to avoid in this scenario, and consequently, we go ahead and turn the power back on here, and we will unplug from this end. We're going to plug into the
battery side. Once again, there's some corrupted audio here, so overdub Matt taking over here. You can see that when I turn that device on, that the power does indeed turn on and operate like you would expect. But we're on mains input power, so let me switch off the output, and you could see there that while we do maintain output power, the power on the device actually blips off for long enough that we wind up losing power on it. It winds up resetting itself, which is probably not ideal under most circumstances. In this case, that power supply is actually not to blame here. The output power from the UPS just gets a little bit dirty in its switchover when you wind up switching off of mains and onto battery power, which isn't ideal in a lot of scenarios, because oftentimes the purpose behind you having a UPS is preventing things like disk operations from being corrupted when you have some kind of a multi-layer caching scenario set up for your storage. If you're in the middle of a write operation on a disk, you don't want that to be interrupted when the power goes off. You want there to be a clean switch over to battery power, at which point the device knows by some kind of other communication chain that it needs to get itself shut off soon, because there's only a limited amount of battery left for it to continue operating on. But ultimately, what's really going to wind up being required in order to get this particular uninterruptible power supply to operate correctly with that sort of a scenario is to have some kind of a capacitance intermediating the connection to the UPS, so that when that power blips off, you're able to continue riding some kind of a stream of power through the blip until you wind up getting back over to battery power. And I've actually got a second clip set up and recorded here that we're going to cut over to demonstrate that that actually is a viable solution. Hey everybody, this is a quick outtake clip from a little later on here, just to demonstrate that thing about capacitance that I said. I actually went ahead and bought this little bee seed brownout protector, I think is the way that it was marketed. I'm not sure if it operates by having a battery inside or supercapacitors or a capacitor or whatever, but it demonstrates the principle that I was trying to talk about for this UPS, which is that you can overcome that little power blip that you get when the input power is cut from it. It's not ideal that it does that in the first place, given that having continuous power is sort of its job, and if you could avoid using this particular unit in the first place, I guess there's certainly maybe some precedent to say that you should. But if you happen to have found yourself in the sort of scenario where it's cheaper to get this unit as well as that, or if you just happen to already be in possession of one of these, I just wanted to show off that this actually does work. This thing seems to claim that it's able to, at 120 volts AC, of course, which is what we're using here in the US, be able to support 12 amps of output, and this delay time. I'm not sure what it means by 3 minutes. I don't think without a battery internally that it could ever possibly support 12 amps of output for 3 minutes. And it certainly doesn't take 3 minutes for it to kick on either.
maybe it means that it takes 3 minutes to charge itself up once you have it plugged into the wall. So anyways, just to demonstrate that this does actually work in principle, I'm going to go ahead and unhook the input power right now. And you can see after that indeed both of these systems did wind up maintaining their power throughout the transition period. So this thing, more or less, it does work. It works in principle. So back to the rest of the video now.
And as it turns out, there wasn't much left to do but wrap up. So I hope you guys enjoyed this look at the Tripp Lite INTERNET750U uninterruptible power supply. We'll be using it in a few of the upcoming videos, and I'll be having a couple more product unboxings in the next couple videos as well, and then we'll start diving into this deeper project that I've been alluding to after that. If you enjoyed this video and think you might enjoy some of my other content, please do take a look at it and consider subscribing. If you liked this video in particular, maybe think about giving it a like, and I will catch all of you in the next video. Thanks for watching.